Okay, thanks, Megan. All right, so yeah, today I'm just gonna give a short overview of our disturbance mapping at LANDFIRE. And I'm gonna focus on the LANDFIRE 2020 release, which is actually coming up next June. So the disturbance layers that I talk about today are kind of how we're mapping them right now. It's very similar to how we mapped the 2016 remap disturbance layers. So I think it'll be, relatable to both, but I just wanted to focus on kind of what we're doing now, because there are a few improvements. For disturbance, the main thing for disturbance is that it affects our vegetation and fuels layers and how we map those. I'm not going to get too much into that because I want to focus on disturbance itself and how we map those, but just know that it's sort of part of this larger workflow within LANDFIRE, but it is also a very valuable standalone product. So this is just an example of annual disturbance for 2016, and just to kind of show you what the final product looks like. This basically has all the different disturbance types labeled there on the right, and then you can see that there's a lot of speckle in some areas. There's a lot of red, which indicates the fire. If you zoom in, you can get a lot more details. So this is just a general overview. And we have mapped annual disturbance since 1999. You can see there in 2011 on the left where my laser pointer, where we added Hawaii. And there were also some pretty major improvements to how we map disturbance around that time as well. We also have a few areas where we were able to map disturbance in some of the insular areas for 2015 and 2016, and that's where those X's are in that table. All of these are available on the LANDFIRE website to download. So for our next release, you can see here it stops at 2016. For our next release, we're going to have 2017 through 2020. And that'll come out in June. What do you get when you get an annual disturbance layer? And this is a little bit wordy, but I think it's really important to look at. So here you have your count of pixels over here, and this is just like a clip of kind of the most numerous in 2016. There's about 145 different categories of disturbance that you get. So each pixel is labeled with some sort of category of disturbance. And there's more for Alaska. So that's for CONUS, and there's more categories for Alaska. But you can see you get the year. So these are 2016. You get the type of disturbance, and there are some unknowns, and I'll talk a little bit more about that. You get the confidence in the type of disturbance. You get the severity of the disturbance, usually low, medium, and high, and then there's some unburned low within TBS. There's the confidence in the severity. There are up to 4 sources. I just put the first one here. There's up to 4 sources per category. And then there's usually a long description telling you exactly kind of where and how that pixel disturbance was derived. And I'll get a little bit more into where we got some of those sources. So I just wanted to show you that because I feel like a lot of people don't know that we have those attributes within each annual disturbance layer. And that's a lot of information. We also provide a historical disturbance, which aggregates 10 years of that annual disturbance. So that's just kind of an example of that, and then we'll get a little bit more into that as well. So how do we do this? How do we map the annual disturbance? We have a process that looks sort of like a hierarchy prioritization of where we get our different data sources and where it sort of lies on this pyramid. So, you know, the most reliable disturbance source for us is the SPIRE program data, and I'll talk more about that. Then we have change, which is sort of LANDFIRE's way of detecting change. Then we have events, which are perimeters that folks submit to us that indicate disturbance, and I'll get more into that. But you can see that there is kind of a hierarchy. This is a simplified version of this table over here, and you can see the disturbance codes that go with that. So we'll start with the fire program data. Basically, the fire program data consists of monitoring trends in burn severity, MTBS, BARC and ravage, and I don't always remember the acronyms there, but these are, the BARC and ravage are very much focused on federal lands in the West, typically for DOI and the Forest Service. MTBS focuses on all fires, but it's, you know, they want their fires to be about 1,000 acres in the West and 500 acres in the East in order to map them. But they all kind of come back to this idea of the difference normalized burn ratio. And what that is exploiting that difference between the spectral response of the burned areas versus healthy vegetation. And so, you know, you can get an indication of what that change is with a before and an after image. So I just wanted to mention that, you know, this is the first time that we are mapping kind of close to the actual year. And so we're having some challenges for 2020 where these programs aren't quite done with a lot of their data. And so we're getting some initial data from them, but it's causing a little bit of differences in our workflow. And that's a result of us trying to actually account for more recent disturbances in LANDFIRE. So the next part I'm going to talk about is these events. So we're getting a little bit lower on that pyramid here. The events are submitted perimeters. They typically come with a disturbance cause. There are several very large federal sources of these events from the Forest Service and the BLM. And they, you know, there's a huge cleanup of these events. And if you look at Brenda's reference video from last time, you'll see kind of what goes into cleaning up that events geodatabase. And so those are all submitted perimeters / polygons of things that agencies or folks that have done treatments, they know that happened in that location. And so here's an example of like different submitted events. And you can see like in 2017, I think there was some emerald ash borer, large polygons going on in the Midwest there. So people account for disturbances in different ways, depending on the agency. So here's 2018. You can see some stuff on the coast over here showing up. That was, I think, a disease out there. And then 2019 was kind of sparse for events. So now I'm going to move on to this change part, and that's LANDFIRE's sort of internal process of detecting change on the landscape. And first thing you got to do that is get your imagery. You need your before and after to detect change. So the first thing we have to do is we break the country up into tiles. We download lots of Landsat imagery, and then we process that imagery. And so part of it is creating an actual composite that we can use for the before and after dates. And the reason we have to do this is because of things like clouds and just anomalies in the atmosphere. And so we really want to get clean imagery so that the change that we're seeing is not due to, random anomalies, but actual change to the vegetation on the ground. So the first thing we do is we are creating these percentile composites, and essentially we get a range of dates of imagery, and then we order the spectral reflectance of those images per pixel. So you can see first they were all kind of mixed up, then we order it, and then we take the 50th percentile. So we know that it's representative of that season. It's not going to be too high, too low, or, somewhere out in left field. So we know that it's fairly representative. Now, what we've also found is, and what we're starting to do for LANDFIRE 2020 is that using the 20th percentile, which actually helps with detecting change with persistently low values with DMBR, and then persistently high values in the 90th percentile is helping us look at changes that are more obvious with DNDVI, the Normalized Difference Vegetation Index. So we get early season imagery, we get late season, we get both of those for before and after disturbance. And so how do we detect that change between those two dates? And so our main form of change detection is this MICA index. So it's a multi-index integrated change analysis. It uses the difference normalized burn ratio, the normalized difference vegetation index, and it has a couple other change vectors that it uses with absolute spectral change. And so really, we're combining a bunch of different stuff and coming up with a good index of change for each tile. We also just look at, the imagery on its own, and we also have some improvement processes that we do that kind of help us really determine, is it change or not? And we call that our SAFER process, where it looks at the pixels of change versus the surrounding neighborhood and kind of gives it a score of, is this really different from the neighborhood? And we also look at previous year disturbance with a random forest model to kind of help confirm that seasonal MICA change. And it really does help us reduce the commission errors. What else we use? We use a burned area product with value-added sensor data. And this comes from Todd Hawbaker with the USGS, and he creates this every year. And, it has all kinds of machine learning, thresholding, temporal compositing. And so it's just another way to look at actual burned area as change. And then our friend Josh Pacat, he has a value-added sensor data that he adds to the BA product to basically corroborate the date and the location of the BA data. So we have a lot of people helping us out trying to confirm what is actual disturbance on the landscape and what is not. So coming back to this kind of tile idea, we have image analysts that actually go through each tile for each year, look at all of that data and decide, basically with a preponderance of evidence from all of these different data sets, whether a disturbance actually happened or not. And so you can kind of rely on LANDFIRE to have someone actually looking at the data. I think a lot of some of the, national change data sets, they're fully automated, but we do actually have folks looking at the data just to confirm. And it's an important part of our process. It takes a lot of time, actually, but it's great. I think it's really helpful. So here's an example. This is an example, and I don't know how clear it is, but you can see this little polygon here, this area here, where it does change. It gets quite a bit lighter in the after image. And And our analyst goes in there and basically says, yep, this was change. And I can tell from the DMBR especially, right? And so they don't have to be super specific about, you know, drawing their polygon around that. They just have to kind of make sure that that it's pretty close, because our model will take the actual pixels of change, of DMBR change within that polygon and work with those. So it makes it a little bit easier for the analyst. But a clear cut, you know, nobody's really going to report that, right? So we're not going to get a submitted event for that. So it's really important for us to do our own kind of change, because if you have a fire coming through here, a clear cut's going to change the fire behavior, you know, so it's pretty important to have those things accounted for. And then this one, you know, this was an example that one of our analysts gave me of a mining expansion. And it's just one of those things that's not super obvious with any of our ways to detect change, our automated ways to detect change. And so that's why it's so important. So he was able to say, hey, you know, this is an area of change that we need to account for. So the next thing that I just want to mention is that we do use the protected area database, which is national, to just provide a little bit more information for the pixels. And that is based on the gap status. So that kind of informs like, okay, well, is it possible that this is actually disturbed? And if you look at the terrestrial 2 category, it kind of gives you an indication that says actually disturbance events are typically suppressed in that category. So we use that information to help label our disturbances in the legend. So then, yeah, we have this this aggregation of 10 years of that annual disturbance information that we put together. And for this one, this was the one from Remap, and it had the years 2007 through 2016. And you can see definite patterns, you know, with the 10 years of disturbance. So the white areas are unknown, and those tend to be mechanical removal. So maybe in the Southeast, where there's a lot of timber industry, and then you can see a lot of fire in the West, obviously. So for LANDFIRE 2020, our historical disturbance layer will encompass the years 2011 through 2020. We also have a fuel disturbance layer, and essentially what that does is it gives us a way to kind of shift the time sense disturbance to help us actually predict fuels on the ground for the current year. And so really what it does is it takes that historical disturbance and it just shifts the years forward a little bit. So we don't have anything after 2016 in fuel disturbance, but we're categorizing the time sense disturbance a little bit differently on that. So I can explain that a little bit more, but it's kind of involved, but it helps for us to predict the fuels on the ground for the current season. So here's just some examples of things that are interesting with some of the annual disturbance. So again, you know, if you look at that white is the unknown, and it's typically ends up being mechanical remove in the fuels layer. So that's sort of an assumption for those unknown losses of vegetation. And then you can see that a little bit here also along the Western Cascades. This is not the one I wanted. This is the one I wanted. So here is an area where, yeah, there's probably some harvest that is not being reported, right? So we just needed to capture that. So here, this is reported. It's probably more on federal land, where this would be probably more on private lands. So that's just a general overview. Our goal for LANDFIRE disturbance is to decrease our latency. So get the disturbance out faster, do it every year, and then work towards imagery updates for vegetation and fuels, and having being able to produce disturbance on an annual basis will help with those other goals. But you can see here for our 2022 release, which is called LANDFIRE 2020, usually the name is based on the last year of disturbance. So LANDFIRE 2020 is coming out in June of 2022. It will include those 4 years of disturbance. The goal for the next release in 2023 is to only have 2 years of disturbance included. And then the next year after that is then we will get down to that annual disturbance that would account for the disturbance from the year before. So that's kind of the goal of, how we want to get there. But that's, I think, all I have. And you have my email there. So, if you don't get questions answered today, we can do that another time and follow up later. But that's all I have.
Inga. Maybe we should work backwards, since the most recent question is about the end of your presentation. But Beth was curious, the large unknown category in the Southeast assumed to be mechanical, that is assumed to be industrial private logging operations. She was
okay. That's the general assumption there. Yeah.
Okay, great.
That's pretty good spread.
Craig had a question about the BARC teams. BARC teams create BARC, B-A-R-C products for each fire they are assigned to. Does LANDFIRE use any of those data for the burned area analysis?
Yeah, so that was, I don't know, maybe you might have missed at the beginning, but yeah, that's part of our fire program data. So we do use BARC. It's actually pretty high in our prioritization right after MTBS. So if there's no MTBS, but there is BARC, then the BARC will be there for sure.
Hi, Inga, Randy here. I think the assumption is that it's hard to capture understory disturbances. And I wondered if you could give us a feel for what magnitude of disturbance has to happen for LANDFIRE to be able to capture it when it's not in a disturbance, a user submitted disturbance polygon when you're using change detection.
Yeah, I mean, that's the $1 million question. Right.
Yeah.
I think, obviously, if you're in a tree life form, then you're going to get that overstory change. If you're in a shrub life form, then, you can get that. But if you do have understory change, it's very difficult. And I think, this is one of the things that we're looking at to utilize LiDAR for is to be able to get at that. And a lot of folks are doing some cool work with terrestrial LiDAR scanners and just looking at what are the differences with different treatments and different disturbances. And if we can get better data for post-disturbance surface fuels, then we can use that to train our models and be able to predict that better. So
makes sense. Thanks, Inga.
Henry asked, how is LANDFIRE working with other disturbance mapping efforts, LCMAP, LCMS, etc.?
Yeah, I mean, I think we know that we've been comparing those three together just to see kind of what we might be able to do to combine some of those efforts here. For what it's worth, I mean, I feel like we have traditionally used everything we can get, and so if we're able to incorporate some of those other data sources, I think that would be wonderful as well. So, the problem is everyone's doing things for different purposes and at different time steps. And so all of those different things have to be considered when we're trying to combine data sets.
Great. April, as you have a question, feel free to unmute yourself and ask it. I'll read it, and then if there's anything that needs to be clarified, feel free. That's the great thing about open office hours is anything goes. So April asks, is the change detection effort integrated with treatment polygons in any way? For instance, if a large polygon is contributed from facts, is the polygon evaluated in any way to only utilize areas that experience a change?
So that comes into our prioritization, right? So if we know there's an event submitted there and we also detect change spectrally, then that has a really high priority in our mapping. So if we have an event but no change, then that's a little bit down here. It's a little bit lower down. If we have change but no event, then you're getting towards the bottom of the pyramid there. So it is taken into account. If we have both, then we're fairly confident something happened there. If we only have one or the other, then we tend to take events over spectral change as what actually happened there. But if we have both, it's the best of both worlds. So I think, does that answer the question, do you think?
Yeah, it does. Thanks. Sorry, this is April.
Hi, April.
We've seen a bit in our work just where perhaps an entire stand gets mapped for the disturbance, and then when we look at like California has provided some change detection data that we've used in recent years, and just going in and saying, oh, well, only a third of the event actually experienced that spectral change. And I was just wondering if you guys see that a lot, and if that's something that like eliminates an event from being considered in a certain area, but more from a restrictive standpoint, I guess. From what you said, it sounded like LANDFIRE tends to go for the more inclusive
yes.
idea that if somebody is saying, hey, something happened here, then you definitely want to include it as a possibility.
Right. And I think that has to do with that surface fuel question that Randy mentioned, is like, we don't know, maybe we're not detecting it, right? But maybe something still happened there. So.
Okay, great. Thank you very much.
April, have you worked much with LANDFIRE disturbance data, and can you tell us where you work? You're in California, I think?
No, I used to be in California, but I'm actually up in Missoula now. I work with Pyrologics. And so we do fieldscape calibrations all over the country. So mostly we just, in our work with Region 5 for the Forest Service, they've had some change detection data available out of UC Irvine for recent years. And so we kind of have been taking closer looks at that with the facts and NIFPORS data, just because those tend to be the largest polygons for us for recent disturbances, and CAL FIRE data. If they give us polygons of saying, hey, we did some kind of treatment in this location, but then once you actually look in it, they just maybe pulled the polygon from a treatment unit or something like that. And then when we look at the change detection data, we're really seeing much less disturbance there than we would if we were just applying the treatment.
Mm-hmm. Mm-hmm. Yeah, that's the trade-off, right? Like if
yeah.
so
and again, it's a project-specific viewpoint versus a CONUS viewpoint. So I was just interested in if there was any of that filtering, or if it was more the inclusive approach.
No, it's an interesting thought, though. I like that idea. It's maybe thinking about things differently there in terms of prioritization. we are evaluating this as we go. I mean, it's been an evolving process, I think, since 1999, right? So
I'm just so impressed with all of the disturbance inputs you guys have. You do great work. So
I wanted to
hey, go. Sorry, go ahead.
Yeah, with thanks. Make sure and jump in next. I wanted to flag a question by Robert Zeal, who probably is not too far from me at the moment, maybe. If an understory disturbance is provided by an agency, but no signal appears in the imagery, are you able to infer some disturbance? And Zeke, feel free to jump in there, but I guess it's sort of related to the pyramid, but there's probably a lot more to it, Inga.
Yeah, typically, I believe, and I would have to double check with Brian Toke, who is our disturbance subject matter expert. But I believe if there's no signal, it defaults to low severity. So if we know there was an event, but there's no DMBR signal, then it'll default to low severity for that event, if that helps.
So this is Zeke, and thanks, Randy, for inviting me to speak up. So I'm thinking of fall hardwood fires, specifically in the east, and a lot of that imagery actually that would show it might actually be leaf off type imagery. I don't know that you're actually using that to detect those, but is there some prospect of doing that? Has anyone tried?
Yeah, we've been talking a lot about using different seasonal imagery, because right now we just kind of focus on the spring and fall. And I think, it doesn't go past, I think, the end of September. So it would still be leaf on for much of the Northeast. But yeah, we've been talking a lot about using different sets of seasonal imagery to try to improve on those very things. And also maybe at some point, getting to, more frequent than annual disturbance. So
I'll just add a little bit to that, Zeke, to your point. So Inga's spot on. And what I will say is, under the good, better, best with our LANDFIRE reference data call, both with plots and polygons, we do ask that if folks have severity information associated with that polygon, to provide that, and that can then help us do a better job of mapping things, knowing that maybe in the case that you're pointing out is like, yeah, from a canopy perspective, you're not going to be able to see the severity from remote sensing. But if we have user contributed information about the severity that occurred on that location, that can help us, particularly as we think about surface fire behavior mapping and things that might need to be changed relative to those surface fuels. So that's a key part that we do have some users that do provide that severity information. Very helpful.
yeah, and to follow up, traditionally in Alaska, we didn't do a lot of the our own sort of native risk change detection for the updates, but they did have more information on severity there, and so we have used their severity information for events in Alaska for sure. I know that yeah.
Hey, Randy, this is Tate with the Fish and Wildlife Service. Thanks for letting me jump in. And, again, thanks for holding these sessions. I think it's really helpful. But now both Zeke and Henry kind of touched on my question, was how we're capturing our things and disturbances in the, prairie regions or those hardwoods. So I think I got everything answered. So I appreciate it.
Yeah, thanks tons, Tate. Yeah, let us know if there are other things that come to mind for sure. And I'm just gonna encourage you guys to all check out the data. Inga, I think it's really great that you have the black background. It makes it easier to see. But zooming in and out on this data is fascinating. I commented to Beth that looking at the disturbances in the southeast is kind of scary because you see all these lines of tornadoes. I assume.
Oh yeah, they had that too. Yeah.
Yeah, you see those. Then in my neck of the woods in the Midwest, you see those straight line winds, some years that are really kind of scary to see. But yeah, I encourage people to download some of the data and zoom in and out and check it out. It's interesting if nothing else. And then important to see how it relates to all the other LANDFIRE data sets. It's definitely not a standalone thing.
Yeah, I mean, I might disagree with you there. I think it can be a standalone thing for a lot of purposes. Yeah. But I guess that's not what you meant. But it does feed into a lot, our other products. But I do feel like it's an underused resource in a lot of ways as a standalone product. So that's, I really wanted to highlight that particular, especially just with all of these attributes, a lot of people don't ever look at those attributes, so.
Great clarification, Inga. Yeah. Put a couple exclamation points on there. But like you said, what I meant to say is it's definitely tied to other data sets as well.
Yeah.
You asked the question, are you able to use remote sensing imagery to depict subsequent vegetative states?
That's that's my biggest goal right now, post-disturbance vegetation mapping. So the biggest problem with that is there's not a lot of training data. And so, I'm hoping to kind of push for that. We're looking at the FFI data set as a potential help for that particular problem, which is where, if they go back and remeasure the plots and look at how things change after disturbance. But I don't know, we're just exploring that now. So anyone out there that has that kind of data, I think would be really helpful to be able to train our models to understand how, what is that vegetation after disturbance, especially more recent disturbances. That's where we're really, we really could use some help there.
So Craig, do you want to unmute yourself and ask your question, or should I just go for it? Okay, so go ahead, Craig.
I'm sorry, it took me a while to find that. I was involved with a few projects in the state of Oregon where we were doing limits of acceptable change, and boy, we wish we would have had this product back then. But I was just wondering if that was something that you would consider as a value-added component, but after I started thinking about it, it's probably, maybe more of a case-by-case situation, like I said. But I just think maybe with a protected area database overlay, that could be something that could be highlighted. I don't know. I'm just kind of throwing some ideas out here.
Could you repeat what you were working on?
Oh, okay. Yeah. This was in the state of Oregon, and we were doing a kind of a planning effort for 5, 10, and 25 years of growth. And we wanted to see what had happened in the past as far as change. And this had to do with a lot of like buildup and urban sprawl. And so we were needing to have a database that would show change detection, and the whole state started to put together this LAC proponent, and it had to do with all different types of landscapes. And so I was just wondering if that was something that some of your users had maybe mentioned as maybe a value added component to have ability to put in these parameters, and then to highlight places that had exceeded the change that was being mandated on certain lands. And I'm especially thinking we were looking at wilderness areas and places that were roadless.
Right.
And with the state of Oregon, it started to spread in Northern California, and Washington started to adopt these parameters that we were formulating. And I just thought maybe it would be great to have had this back then, this product you have.
Yeah.
But I'm just wondering if any of your users had mentioned, gosh, this would be great to have this as, like I said, a value added component. Yeah, anyway, just throwing that out there.
Yeah, it seems really interesting. I like that. Oh, Henry's raising his hand.
Yeah, so I guess I'll jump in here quick. So I think we've looked at it in a few ways. There's some current stuff that we're actually looking at right now with some of the, I'll say, state in transition. And that's thinking maybe not in the full terms of what you're talking about here with, these limits of acceptable change, but it's looking at it from an ecological perspective to think about what amount of change, occurs over time. So I think it'd be worth having a more detailed conversation with you to see exactly the parameters with that. But that is a work in progress that we're currently doing right now. How do we take, kind of that successional change, factor that into what Inga talked about with the frequency and the latency of the products, and see if, and we're looking at this more from kind of growth yield curves, for instance, so to that limit of acceptable change of how much, change might occur in a given ecosystem, which then of course ties back to a specific vegetation type. So there is some of that we're working on right now. In fact, those tied to the state and transition models that we have, but then take it a step further as we look at vegetation. The long-term goal is to look at that relative to fuels as well, relative to the types of change. And then I'll also add this, seeing that Chuck's on here. We had done some work with Chuck and Karen Short, in the past, looking at what we called at the time optimization and efficacy, which was looking at the durability of treatments over time, which again I think fits into this concept of limits of acceptable change. And so that's another piece that has worked out relative to that optimization and efficacy, and the durability of treatments is focused more on forested types, but there is some work going on with the Joint Fire Science Program to look at how that can be expanded to the rangeland, shrubland types, given that there's not as much science in that area. So hopefully that's helpful, and I'd like to talk with you. We're probably scratching part of the itch, but I don't know to the full extent of what you're talking about if we're scratching it all the way.
Right. Thanks, Henry. You bet. I look forward to that.
We still have some more time if anybody else wants to chime in and has questions. Feel free. All right, I'm going to launch a quick evaluation poll while folks are thinking about if they have any other questions left. Please take that when you have a second. These evaluate. Can you see it, Randy, or no?
I think I accidentally ended it.
That's so funny.
I'm so sorry. You shouldn't give me control, Megan.
No worries. Hold on, let me try again. Relaunch. Okay, sweet. Well, like I mentioned, this webinar was recorded, and the recording will be on the LANDFIRE YouTube channel. Go ahead, Z, if you want to unmute yourself and ask the question. We're all ears. That's what we're here for.
Well, I actually just wanted to show an example of one of the situations that we face. I did get a chance to talk to Randy Swati about it earlier this fall. I was FBAN on the Greenwood fire in northern Minnesota, and just some of the challenges we face in mapping and interpretation of the fuels. So I don't know if it's maybe something to do later offline with someone more specific, but I could certainly show something here and whet your appetite.
Go for it.
I don't know. Will it let me share my screen? Yeah, it will.
I think it should. If I need to give you another permission, let me know.
So
good to go.
Yeah, let's see if I can minimize that. See if I can get the perimeter. There we go. So the Greenwood fire actually was a pretty good sized fire in northern Minnesota, late August and September. I don't know if it makes sense to you folks, but you can see that the landscape was largely coniferous, and it certainly had some variation. There's hardwoods in the vicinity and so forth. But one of the real challenges we had is that you can see that there were real impediments, to spread, and it was maybe not often easily discernible from the cover or the fuels. The second thing that we noted and struggled with is this very light green color, which tended to dominate the heart of the burned area, as well as a lot of areas that didn't burn as well. Is that boreal acid acidic peatland, which is a pretty general classification and makes it difficult for us to distinguish burnable from non-burnable in those wetland categories. It was I think one of the things that really made it hard, the folks were changing the 161 to 165, and it was changing obviously a whole chunk of the landscape, whether that was appropriate or not. So I think I know that we've spent a fair amount of time, folks in the national forests up across the Upper Peninsula, northern Wisconsin into Minnesota, talking and thinking and trying to figure out how to improve that classification. But it's certainly something that's still out there for us to solve. The other thing I wanted to point out is that this area of northern Minnesota is a real pinery, that a lot of red pine, and the fuel types here are showing it as 165, and that may not be too far off in terms of fuels, but it's really a challenge for us to understand and appreciate what's going on. You can see here this redder color is truly red pine, and as you walk around, you can see how much of it there is. A lot of it's planted, but it probably always was a pinery up there. This Great Lakes transition forest, I think, is the folks up there call it. But interestingly, the light green color is not red pine or not even pine. It's mapped as balsam and spruce. And as Randy and I talked about it, it became real clear that one of the things that we as the local, folks in an area like this, that we probably don't do a good enough job of interacting with you as you're working to map these projects. And I really feel like if we had been more engaged, that the maps, the landscapes, even perhaps some of the boreal acid peatland might have been mapped somewhat differently. And I really think that that's one of the messages I take home from this, is that when we're engaged, and I've seen it in various parts of the country, your ability to actually ferret out the details is really valuable. That's all I wanted to show.
I think that's a great message, and I really appreciate that.
And I want to put an exclamation point on Zeke's point that, the boreal acid peatlands are still a challenge for us to solve, whether it's in the BPS data, the historical ecosystems data, or current. There are multiple challenges, both with mapping the concept as described and refining the concept. It's really, really hard. It's really, really hard. So I think, there's still and it's such an important ecosystem for fire managers, for hydrology, for tons of values in the Great Lakes region. So looking forward to hearing from you guys over the years as we try to refine how we map and understand that broad ecosystem.
That might be our next conversation, Randy. I have an advantage. We live in the same town, so I get his attention more often than some others.
That's great.
Are there any final questions? Go ahead, Inga.
Well, I would just kind of reemphasize that, the more you let us know what the problems are, the easier it is for us to fix them. So definitely CC LANDFIRE help for any of those issues that you encounter. And if you're having a conversation with Randy about it or whatever, because then it gets it on our radar to try to address in the next round. So
that's a good point, Inga. I forget to do that myself sometimes, clearly, to get those in the official record with the help desk.
Yeah, just definitely helps us keep track of that stuff.
This is April, and I just wanted to make more of a comment that this was really helpful and great. And Inga, at the beginning of your presentation, you noted that this was really focusing on the disturbances and the disturbance processing, but that these also feed into, the existing veg and the fuels veg. And for a future workshop, I think that I'd be really interested to delve kind of into those two components a bit more as well.
Got that, Megan?
Got it. Yeah, and I think, as well, I won't say anything about the pandemic, but it seems like workshops are going to become maybe more likely to happen in the future. So I'm hopeful about that, and definitely take note of your question or your comment. Thanks, April. All right. Well, thank you for attending this open office hour. Again, mark your calendar for December 2nd. We haven't picked a topic yet, and I'm wondering if maybe we should just do that on purpose, Randy, and leave it sort of open. Since it's our last one of the year, it feels maybe appropriate. We've had over 200 people register for these open office hours since January. So maybe what we should do is go through the registrants and the questions, and people have sort of sent suggestions for how we can make these office hours valuable to all of you. And maybe we should make that just tie up loose ends and see if we're going to continue office hours into 2022. So that's all I have for today. Again, thank you so much. Inga, you have a wonderful delivery of very complex topics, and I'm so glad I have my job and not yours. And thanks, Randy, for your support. Thanks for bearing with me as I have the wonderful fall cold, and everybody have a wonderful Halloween. So
Thanks, Megan. Thanks, Randy.
Thanks, Inga.
Thanks, everybody.
Thank you. Bye.
Have a good one.